This is V. Srinivasa, working as Assistant Professor in Mathematics in Mlritm. Today, we will discuss multiple integrals. So, this is one of the important chapter. So, this chapter belongs to the subject of differential equations and vector calculus. So, here most of the students felt integration is very difficult. So today I want to introduce the integration, which is not a single integration, it's a multiple integrals. So here first of all, what is a integration? So here so many members, so integration meaning, so they feel that is integration is one of the topic of mathematics, but that is in our day-to-day life, that integration is one of the part. So here integration and differentiation. Differentiation is nothing but to decrease the quantity. Integration is nothing but to increase the quantity. So in our life, integration, everyone have to follow the integration and differentiation also. So here our expenses will follow the differentiation, and our income will follow the integration. So here multiple sources, multiple integrals. So here today we are going to discuss multiple integrals, one topic, that is a double integrals. So here double integrals I will introduce. So in these multiple integrals, the contents are, the first one is evaluation of double integrals in Cartesian form and evaluation of double integrals in polar form. So here already I explained about multiple integrals, that is it is double integrals and triple integrals, single integrals, double integrals, triple integrals. So here single integrals is in a student, that is students will learn in intermediate level only. So coming to the double integral and triple integral, they will learn in this engineering. So here I want to introduce for this video for especially for first year students, so who studying BTech first year and who are studying in degree first year also, it is there. So here evaluation of double integrals in Cartesian form is the first topic, and evaluation of double integrals in polar form, change of variables in double integrals, change of order of integration in double integrals, and evaluation of integrals, evaluation of triple integrals, and change of variables in triple integrals. These are the topics, and finally applications of this multiple integrals. So here using double integrals we have to find area of the given curve, and using triple integrals we have to find volume of the solids. This is the total content of our topic, my topic. So here first today I will introduce about double integrals. So how to use the double integrals, right? So here double integrals can be calculated. Double integral particularly we will use when the function is function having two variables. So if the function having one variable, we will use single integral. The functions are two variables, that means one source, that is a single integral. More than one source, suppose two sources are there, so source 1 is represented by x, source 2 is represented by y. So in that case, how to integrate, how to earn, that we have to discuss now. So here double integrals can be classified into three types. So evaluation of double integrals can be classified into three ways. So the first one is, so both are constants, and second one is y is constant and x is variables, and third one is x is variable and y is constant. X is constant and y is variable. So here three types of integrals we are going to evaluate. So this is a simple thing. So both are constants. We know that you have two sources. One source is fixed, another source is random. That suppose you are doing one job, that is a fixed, that income from through that job is fixed, and another one is a variable that will varies. So similarly, so suppose both are constants, some persons will do the two jobs. So that is a both are constants. So similarly, x, y, our generally in mathematics we will use the language of xy. Xy is nothing but second person, third person, like that only. So here first when y1, y2 are the functions of x. So first case, I am going to introduce first case. Y1, y2 are the functions of x and x1 comma x2 are constants. Then the function f of x comma y is integrated with respect to y first, because y1, y2 are the functions of x. So that's what integrate with respect to y first, keeping x terms are constant within the limits y1 and y2, and then the resultant expression is integrated with respect to x within the given constants x1 and x2. So it's very simple. Double integral of here double integral of f of x comma y dx dy. So here limits I specified particularly, x is in terms of y and y is constants. So here that is the first case. And while coming to the second case, when x1 comma x2 are functions of y and y1 comma y2 are constants. So what I am telling, this is quite opposite of that. So x1 comma x2 are functions of y and y1 comma y2 are constants. Then f of x comma y, which we have to integrate first, f of x comma y is first integrated with respect to x and then with respect to y. So while doing with respect to x, keeping y term should be constant. So that's what here, first we have to integrate with respect to x, keeping y fixed in the limits x1 to x2, and then the resultant expression can be integrated with respect to y between the limits y1 and y2. Then we get the answer. So that is the second way. First way, y1, y2 are the functions of x, x terms are constant. In the second case, x1, x2 are the functions of y and y is constant. And coming to the third case, in the third case both are constants. When x1, x2 are all constants, x1, x2, y1, y2, all x terms constant, y terms constant. So then we have to integrate y first and then x, or vice versa. We can follow any order, no problem. So I think I thought you understood. Everyone understood the concept of these double integrals. Double integral, particularly double integral, is used when the function is more than two variables. So more than one variable, sorry, two variables, that is x and y. At that case, we have to apply this double integral. And in this double integral also, we have to integrate in three ways. The first way is y is in terms of x and x constants. Second way is x is in terms of y and y constants. And third way is both are constants. That means we will see three types of problems in double integral. If we take any problem in Cartesian form of the double integral, only three types of problems. The first one is both are constants, and one is y constant x variables, x constant y variables. So any problem we can take in this double integral that belongs to any one of these three cases only. Here one more thing, Cartesian form, polar form. So Cartesian means it is in terms of xy. If the given problem is expressed in terms of x and y, that is called a Cartesian form. Suppose the given problem in terms of r and theta, that is a polar form. Today I will explain only Cartesian form. So Cartesian form means students, how to identify whether it is a Cartesian form or polar form? Simply by seeing the given problem in terms of x and y, that is a Cartesian form, right? So here first I will solve one problem. The first question is evaluate integral 1 to 2 and 1 to 3 xy square dx dy. Yes, every students. So this is the problem having both are constants. This is the problem having both are constants. So here, so there is no specific order. As for the given problem, we can follow. So in the given problem, dx is given first. So that's what we have to integrate with respect to x and then with respect to y. If we can change the order also, no problem when both are constants. So here this can be solved. So first we will integrate with respect to x. So here at that time keeping y terms are constants. So here y square is constant. Integral of x dx. Integral of x dx is x square by 2. So within the limits 1 to 3 and dy. Yeah, we know first what I am doing with respect to x, keeping y terms are with respect to x, keeping y terms are constants. So that's what here y square is a constant. Integral of x dx is x square by 2. Then what are the x limits? 1 to 3. So here substitute the limits here. Integral 1 to 2 y square into, so first upper limit. First upper limit, that is 3 square by 2. In place of x I am substituting 3 square by 2 minus lower limit. Lower limit is 1 square by 2. 1 square by 2 into dy. So that is equal to integral 1 to 2. Integral 1 to 2. So y square into, when I apply the limits, so 3 square by 2. So 3 square means 9. 9 by 2 and 1 square by 2. 1 square by 2 means 1 by 2. 9 minus 1, 8. 8 by 2, 4. So this is 4 into dy. Now it's time for doing with respect to y. So here with respect to y, so here integral 1 to 2 y square dy. So with respect to y, we know that this here, in order to do these problems, everyone have to memorize the formulas, that is x power n, y, x power n, and basic formulas. So x power n or y power n, the formula is x power n plus 1 by n plus 1. I am applying in these, this is the formula. Integral of x power n dx is equal to x power n plus 1 by n plus 1. Using this formula only I am doing this problem. So that is equal to 4 into integral of y square. Integral of y square is y cube by 3, limits 1 to 2. So here apply the upper minus lower again. So 4 into upper limit, 2 cube. 2 cube means 8, 8 by 3 minus 1 cube, that is 1 by 3. So that is equal to 8 minus 3 is LCM, 8 minus 1, 7. 4 sevens are 28 by 3. So that is the answer. Is it clear, everyone? This is very easy to understand. Here in this problem, both the variables limits are constants. That means x limits, y limits, both are constants. So here that's what we can get easily. First I applied with respect to x. As per the given problem, dx is first. That's what I applied with respect to first. At that time, keeping y terms constant. Here y square is a constant. X square by 2. So then apply the limits, and then it gets converted into only y terms. Then it's time for applying y. Same formula I applied, integral of y square, that is y cube by 3. Then finally we got the answer. So this is the one case. In this, what is the case of this? In the double integral, both the variables are constant. That is x limits, y limits, both the limits are constants. This is the problem, right? Next, we will discuss one more problem. In this problem, so here y terms, here look at this problem. In this problem, one of the limits are 0 to x square, another limits are 0 to 5. The most important thing is 0 to x square is the limits of x or y. 0 to 5 is the limits of x or y. The most of the students confuse here only. So it's very easy to identify. So always remember y in terms of x or x in terms of y. Don't write x is equal to x in terms of x only. So that's what here is very clear to classify this. So first limits and the second limits. What I am telling here, 0 to x square, that is in terms of x. Limits are in terms of x. That's what that limits are y limits. Y is equal to 0 to x square. So and rest of the automatically rest of the one is x limits, 0 to 5. 0 to 5. So here x into x square, I am multiplying inside x cube plus x into y square. So here actually as per the given problem, dx dy is there. But here I wrote y limits first. That's what. So I need to write dy first and then dx. Because I wrote y limits. As for the given problem, y limits first is there. But generally it is given as dx dy. As for the limits order, we can change it. So as for the limits order, y limits first, that's what I wrote dy first and then dx. So just now I explained the concept of this. Here this belongs to y in terms of x, so x constants. Previous problem, both are constants. This problem is concerned to y in terms of x and x constants. There already I explained. So in this situation, what we have to do? First, we have to integrate with respect to y, keeping x terms constant, and then integrate with respect to x. That's the rule, simple rule. So both are constant, we can follow any order, no problem. So this is particularly limits are given. In this y is variable, y in terms of x is given and x is constants. That's what first we have to integrate with respect to y, keeping x terms are constant. So that is equal to, so here first x terms are constant, x limit 0 to 5 only. So integral of x cube dy. Integral of x cube dy is, x cube is a constant, into integral of 1 dy is y, plus x terms are constant, that's I am telling now, x terms are constant. Integral of y square dy is y cube by 3, y cube by 3. So limits are 0 to x square dx. So here I applied first with respect to y. So now in place of y only we have to substitute the limits. So that is equal to integral 0 to 5, integral 0 to 5. In place of y I am substituting the limits, that is x cube into x square, x cube into x square plus x into x square whole cube, x square whole cube by 3, x square whole cube by 3 into dx. So that is equal to, now all look at this, all converted in terms of x. Y rule is over. Then it's time for x rule. We have to integrate with respect to x. Before that, we can arrange in a correct order. So integral 0 to x, simplified form, x cube into x square. We know when bases are equal, power should be added. That is x power 5 plus this is x square whole cube. X square whole cube means x square into x square into x square. So when bases are equal, power should be added. So that is 2 plus 2 plus 2, 6. 6, one more x is there, x power 7. X power 7. So by 3 dx. X power 7 by 3 dx. So here some people, a small confusion here, some people that is by mistake, they can add 2 plus 3. 2 plus 3. So that's what here x power 5. X power 5 into x, x power 6. That's wrong. So here it's very clear. X square whole cube means x square 3 times. So x square 3 times means x square into x square into x square. We have to add 2 plus 2 plus 2, 6, x power 6. So x power 6, already one more x is there, x power 7 by 3. Now we have to apply integration with respect to x. So with respect to x, x cube integration, x power 5 integration. So x power 5 integration, we know x power n formula. X power n is x power n plus 1 by n plus 1. So x power 5 integration, x power 6 by 6, x power 6 by 6 plus x power 7. X power 7 integration, x power 8 by 7, x power 8 by 8 into 3. Already 3 is there, 8 into 3. Limits 0 to 5. Limits 0 to 5. So here, so that is x power, first I have to substitute the limits here. First upper limit, always we know the order of the limits, upper limit minus lower limit. So that is 5 power 6 by 6 plus 5 power 8, 5 power 8 by 8 into 3, 24. So this is the answer. So we'll get some in points, some answer. So that is the answer. So understood the concept. This is the concept of y in terms of x and x constants. So I explained initially there are 3 ways, that is 3 ways of evaluating double integrals. So in the first problem I explained when both are constants how to do. So in the second problem I explained y in terms of x and x constant. Finally x in terms of y, y constant. That is the third case. Now we will discuss. So look at this problem. So in this problem, it's very clear. One of the limit is 0 to a, another limit is 0 to square root of a square minus y square. Square root of a square minus x square minus y square dx dy. So here it's very clear to identify the limits. So first we'll try to identify the limits. So dear students, here it's very easy to identify the limits. Already I said always x expressed in terms of y or y expressed in terms of x. So here first one limits in terms of y. That's what these are x limits. So that is x limits, x is equal to 0 to square root of a square minus y square. That are the x limits. And then y limits, y is equal to 0 to a. That are the y limits. So the given integrand, this is called integrand. Integrand is square root of a square minus y square minus x square minus x square. So here first x limits are there. That's what as for the given order dx is correct only, and dy. Okay, now here in this problem x in terms of y and y is constants. In this problem x in terms of y constants. That's what first we have to integrate with respect to x keeping y terms constant, and then with respect to y within the given limits. So that's what here what I have to apply the first I have to apply with respect to x keeping y terms constant. So here this can be written as integral 0 to a integral 0 to x limit square root of a square minus y square. So here there is a formula involved here. That's what here I'm expressing the given integrand as square root of a square minus y square whole square minus x square dx dy. Yeah, the reason is there is a formula. That formula is square root of integral of a square minus x square dx is equal to formula x by 2 into square root of a square minus x square plus a square by 2 into sine inverse x by a. That is the formula we have to apply now. So here in place of a, what is there? Square root of a square minus y square. So here we have one doubt. A is constant, but y is not a constant. But initially what I explained, while doing with respect to x, y terms are constant. So that's what a constant, y also constant. So that's what a square minus y square totally constant. So here when I apply this formula, now I'm going to apply this formula. So in this when compared to this problem, this formula, in place of a, square root of a square minus y square is there. In place of x, x is there. So now we will write the formula, that is equal to integral 0 to a, only inner integral. So that is x by 2 into square root of a square minus x square. That means this whole thing, square root of a square minus y square whole square minus x square. So x by 2 into square root of a square minus x square plus a square by 2. A square by 2 means here what I am telling a is square root of a square minus y square. Square root to square root cancel. That means a square minus y square by a square minus y square by 2 into sine inverse x by a So x by a, what is a? A is square root of a square minus y square. So whole bracket, this is whole bracket, limits 0 to square root of a square minus y square. So that means here in place of x or y I have to substitute the limits. Here I did with respect to x integration. That's what I have to substitute the limits in place of x. So that is equal to integral 0 to a. Now I am substituting the limits, upper minus lower limits in place of x. So simple, when I substitute upper limit in place of x here, square root of a square minus y square whole square, both will be cancelled. That means 0. When I substitute upper limit in the first term, in this term, when I substitute upper limit, that becomes 0 plus. So that is it's very easy to say that x square that is, and first term is 0 when I substitute upper limit. And coming to the second term, just I am substituting upper limit. Second term, a square minus y square, a square minus y square by 2 into a square minus y square by 2 into, when I substitute in place of square root of a square minus y square, square root of a square minus y square and square root of a square minus y square cancel. That is 1. Sin inverse of 1. So this is sin inverse of 1. This is only upper limit. Only upper limit. Minus lower limit. Lower limit means in place of x, if I substitute 0, then it becomes 0. Because x by 2, 0 by 2 plus a square minus y square by 2, a square minus y square by 2 into, when I substitute x value 0, this is sin inverse of 0, sin inverse of 0, whole bracket. This is the whole limits, whole bracket dx. So so with respect to x completed, whole bracket dy. Here also I need to write dy. Okay, so that is equal to integral 0 to a, so limits, I applied the upper and lower limits. This is 1, sin inverse 1. That means what it remains finally, a square minus y square by 2 into sin inverse 1. So this is sin inverse 0. We know sin inverse 0 is 0. Sin inverse 0 is 0. So sin inverse 1 is 90 degrees. Sin inverse 1, 90. So pi by 2 into 2, pi by 4. I am writing pi by 4 outside. Integral 0 to a square minus y square, a square minus y square into dy. So that is equal to pi by 4 into integral 0 to a. Now I am doing with respect to y. So keeping a term, a always fixed, a square into integral of 1 dy is y minus a y square integration, y cube by 3, limits 0 to a. So that is pi by 4 into, when I apply the limits in place of ya, this is a cube minus, so a cube by 3. So that is equal to 3 is LCM, 3a cube minus a cube, 2a cube, 2a cube by 3, 2 in 4, 2 times cancel. So that is finally pi a cube, 2 pi a cube by 4 into 3, 12. So here 3 LCM, that is 2a cube by 3, 2 in 4, 2 times cancel, 2 3s are 6. Pi a cube by 6 is the answer. Once again listen students, here is very easy. This is the third case. Already explained that is 3 cases. First case is both are constants. And the second case is, so y in terms of x and x constants. Now x in terms of y and y constants. In this problem, it's very clear to identify x limits. X limits are 0 to square root of a square minus y square, because these are it is expressed in terms of y, and y limits are 0 to a. So that's what here first I have to integrate with respect to x. I integrated with respect to x, square root of a square minus y square minus x square dx dy. So in this problem, this is an important formula involved, square root of a square minus x square dx. So using this formula, I solved this one. First I did with respect to x using this formula, and I applied the limits. Finally I got sin inverse a square minus y square by 2 into sin inverse of 1 plus minus a square minus y square into sin inverse of 0. Everybody knows sin inverse of 0 is 0, sin inverse of 1 is 90. So a square minus y square by 2 into 90, pi by 2. Pi by 2 into 2, pi by 4. So that is 0 to a square minus y square dy. Now it's time for doing with respect to y. So that is pi by 4 into integral of 0 to a square. That is integral of a square dy. That becomes a square y minus integral of y square is y cube by 3. So that is 0 to a we get. So when I apply the limits of upper and lower, first upper limit in place of y, I wrote a. So that is a square into a cube minus a cube by 3. A cube minus a cube by 3, that is 2a cube by 3. Already pi by 4 is there. 2 in 4, 2 times cancel. 2 3s are 6. Pi a cube by 6. That is the answer. So this is my topic today. That is in the part of multiple integrals, that is double integral. I explained in double integral 3 cases. So thank you everyone.